types of stress. So, when deforming force produces change in length of the material body, then the stress is called longitudinal stress. So, first type of stress is longitudinal stress. Now, I already said when deformation takes place in length, the stress is longitudinal stress. Now, again we consider that rod, or we can take one cylindrical wire. This is one cylindrical wire. And if we apply a force to this cylindrical wire in this direction, what happens? This cylindrical wire gets extended because of application of this force, and if original length of the wire is L, the extension produced in the wire is small l. Now here, because of application of this deforming force, the length of this cylindrical wire increases, and in this case, the stress is called tensile stress, because here length increases, and that's why stress is called tensile stress. Now, how this tensile stress can be formulated? It can be written as again force upon area. Which force again? Internal restoring force, or we can write applied force upon cross-sectional area. So, applied force is in this direction. That we are applying force means we are applying some load there, and that load has some mass, for example m, and if we multiply that mass by g, then we say that this is force, and we can write here now instead of F as mg. Now, how will be cross-sectional area of this? Radius of this cylindrical wire is r, and then area we can write as cross-sectional area of this is pi square. And that's why tensile stress can be written as F by A, that is mg divided by pi r square. Actually, obviously this end should be fixed there, and we are applying force in this direction. Then what happens? Length of this cylindrical wire, or we can say rod, increases. By how much this length increases? Small l. Original length of this cylindrical rod or wire is capital L. Force is applied in this direction. Force is applied by application of load there, which is having mass m, and we know that mg is force. And cross-sectional area of this is pi r square. So we can write tensile stress is equal to internal elastic or internal restoring force divided by area. Means applied force upon area means mg divided by pi r square. This is all about tensile stress. Now, if same rod is taken and we apply force to this wire or rod in this direction. Now suppose that this end is again fixed, or we can say that it's okay. Now what happens? When force is applied in this direction, instead of increase in length, the length of the rod decreases. Now, by how much quantity this length decreases? Original length of the rod is suppose L. Now, length of the rod decreases by, for example, L. So this is actually decrease in length. Now in this case what happened? Length decreased. So in this case rod gets compressed, and so that we say this stress as compressive stress. compressive stress, in the name of that meaning is there. Length is decreased. Length of the rod is decreased, length of the wire is decreased. And again formula for this is F by A. F means FR means F by A. F is again, we are applying force, means it should be equal to mg. We must apply load, then we can apply force there. And that is equal to mg divided by pi square. So this is compressive stress. And both, now both, which both? Firstly we studied tensile stress, and this compressive stress, both combined is called longitudinal stress. What is longitudinal stress? When deformation takes place in the length of the cylindrical wire, in the material body. We need not to take particular example, but we say that when deformation takes place in the length of the material body, then the stress is called longitudinal stress. And in that, tensile stress comes as well as compressive stress also comes. Means here in both the cases, in A and B, in both the cases, what happened? Deformation takes place in length there, and that's why it is longitudinal stress. So SI unit of this is again Newton per meter square, CGS unit is dyne per centimeter square, dimensions are same as stress there. Actually again I have to tell one thing here. Originally we studied stress. What is stress? And here we studied longitudinal stress. So stress is not a vector, it is not a scalar. It is tensor quantity, but it can be treated as scalar. So this is all about the longitudinal stress. So whenever there is change in length, whenever there is deformation in length, we say that it is longitudinal stress. Now second type of stress is volume stress. Now what is volume stress? When deformation takes place in volume of the body, then the stress is called volume stress. Now for this we will take one example of one rubber bladder there, and here is a rubber bladder, and for example we are applying force from all sides to this bladder. We are applying force from all sides. Because of this application of force, what happens? If its original volume is V, then its final volume becomes, for example, V minus dV, means change in volume is dV. Now actually when we apply force from all sides to this rubber bladder, there is decrease in volume, and this decrease in volume is dV, and in such a case, in this case, the stress is called volume stress. Volume stress can be written as, again, force upon area. Now here is force, we are applying force, and we have to take area of this, etc., etc. And we know that force upon area is dP, that is pressure, and this is volume stress. Means in this case volume stress is dP, that is F by A, and we know that pressure is not a vector quantity, actually it is scalar, but stress we call it as tensor. It can be treated as again scalar. So we know SI unit, we know dimensions. Now I will not tell about all those things. So this is all about your volume stress. Here deformation takes place in volume, and when deformation takes place in volume, the stress is called volume stress. Original volume of this rubber bladder is V. We are applying force from all sides, and because of that the volume of this rubber bladder decreases, and the stress is called volume stress, and that is F by A, that is dP. So this is volume stress. Now third type of stress is shearing stress. Third type of stress is shearing stress. Now for that we take one example. Now firstly we will explain. I explain what is shearing stress there. So when deformation takes place in volume there.
Yes.
When deformation takes place in shape of the material body. When deformation takes place in shape of the material body, then the stress is called shearing stress. When deformation should be in shape. For this we take one example. We take one cylinder whose one end is fixed there, and we apply some tangential force to the top of this cylinder, and because of this application of tangential force, this cylinder has a shape like this. Means this layer displaces to some distance, that is dx. If original length of the cylinder is L, this layer displaces through distance dx there. Now here shape of the cylinder changes, deformation is in the shape, and that's why stress is called shearing stress. It is again written as F by A. F is again applied force. Here force is tangential, perpendicular to this surface, and this F by A is shearing stress. We can take another example of cube also. If we take one cube and bottom of the cube is fixed, and if we apply tangential force to the top surface of the cube there, what happens? This cube, or we take one front face of the cube, and that front face of the cube becomes parallel. Means there is lateral displacement of each layer in this case, because we are applying tangential force to the top there, and in that case also we can say that F by A is shearing stress. SI unit of this is again Newton per meter square, CJS unit you know, etc. What happens here actually? Why it is called shearing stress? Because your deformation is in shape. So this is your shearing stress. So we studied three types of stresses. First one is longitudinal stress. When deformation is in length, the stress is longitudinal stress. Second one is volume stress. When deformation is in size or volume we can say, then the stress is volume stress. And when deformation is in the shape, then the stress is called shearing stress. So all these are types of stresses. First one is longitudinal stress, another one is volume stress, and third one is shearing stress. So in this class we studied elasticity, plasticity, deforming force, deformation, then what is stress, what are the types of stress, etc. etc. Finally, what is elasticity? It is the property by virtue of which body regains its original dimensions after removal of external deforming force. And what is plasticity? The property by virtue of which body does not regain to its original dimensions after removal of external deforming force. In elastic bodies, internal restoring force is very small, and in plastic bodies, in elastic bodies, internal restoring force created is very large, and in plastic bodies, internal restoring force created is very small. And the bodies which have property of elasticity are called elastic bodies, and the bodies which have property of plasticity are called plastic bodies. And what is the difference between elasticity and plasticity, that we also studied in this class. So in next class, we will study what is strain, what are the types of strain, then what is Hooke's law, what are elastic constants, what is modulus of elasticity, etc. etc.